Okay, this is the video for the second page or the back side of our comprehensive review, and it starts off with continuity. Okay, continuity. There are three different things that you need to be aware of for continuity. Okay, we either have continuousness, right? No gaps, no jumps, no whatevers. The left side approaches the right side, and you have a closed dot at that value. Right, we always call that value A. So this is a continuous function. No gaps, no jumps. We have point discontinuity if at that point we have an open circle. Right? The y value from the left is the same as the y value from the right, but we do not have any equality, so this is where we have point discontinuity. The last one would be a jump discontinuity, where the two y values are far away from each other at that x value. Okay, so here we have two separate y values. Here we have one y value. Here we have one y value. Okay, so that's what we're checking when we do questions like be able to describe the continuity at the constraints. Okay, the constraints are your numbers here, right? -2 would be one of your constraints, and +3 is your other constraint. So let's do a little sketch and see if we can figure this out. So we have -2, right? That's where we put in a vertically dashed line, and +3. So we want to see what is happening at -2, and we want to see what's happening at -3. So the equation on the left of -2 is x squared minus 4. The equation in the middle is this absolute value equation, x plus 1. And then the equation to the right of +3 is 2 root x minus 2. So if we want to know what is going on here, what's going on at -2, we're going to plug -2 into this equation, and we're going to plug -2 into that equation. And we're going to look at what we get when you plug -2 into both of those. Okay, so let's see what we get. We get -2 quantity squared minus 4, which is 0. Okay, because what's -2 squared? That's a +4, because squaring makes things positive. 4 minus 4 is 0. So from the left side, the y value goes to 0. Right, the graph is over there somewhere. Oh, it's not a closed circle, is it? It is an open circle because it says less than. Less than -2 means we have an open circle. Okay, and what happens when we plug -2 into your absolute value? The negative of -2 plus 1. Okay, is the negative of -1, which is -1. So on the right side, the graph is going to come in here to -1, and on the left side, the graph is going to come out here at 0. So what kind of continuity would you say is occurring at -2? This would be a jump discontinuity. The y values are not the same from the left and from the right. Continuity at x equals -2. Jump discontinuity at x equals -2. The y value from the left is 0. The y value from the right is -1. And then we're going to do a similar thing for what's happening at 3. We're going to plug 3 into your absolute value equation, and we're going to plug 3 into your square root equation, and we're going to see what number they give us. So let's come over here and do that. The negative of 3 plus 1 is -4. 1, 2, 3, 4. Open circle at -4 because it's less than +3. And then let's see, 2 times the square root of 3, 2 times the square root of 3 minus 2 is 2 roots of 3 minus 2, which is something. Let me check. 1.46. Sorry, we're supposed to only have pretty numbers, but oh well, 1.46, which is up here. So clearly these two aren't close to each other either, so you're going to have another jump discontinuity at this point also. So we have, there you go. Okay, so those are what we're looking for. Are the y values the same? Are the y values different? And does it be continuous? Okay, number 6, here we have your composition. We're going to take the g equation and plug it into the f. That's what f of g means. It means take your g equation and replace it in f. And now we do all of the simplification, right? We're going to square this binomial. We're going to multiply that one by -2. We're going to do all the work, and so we simplify it down to one answer. Okay, so there's x minus 2 squared, and then we have minus 2x plus 4 when I distribute, and I have a minus 5. So your total function should look like this. So here we have the answer when we take the f and plug it into g. We get x squared minus 2x minus 7. So we want to be able to identify odd and even from equations and graphs. So here are your equations. So what we want to do to see if we have an even, we always test for even first, is you plug in a negative x into your equation. Okay, this is our first test. Do we see if it's even? So you replace x with negative x. Okay, and you do all of your simplification. So negative x squared. If I square a negative number, I always get a positive. So this is the same as normal 2x squared minus 8. And then I compare. Is that the same as your original function? Yes, it is. That means this is an even function. So you replace x with negative x, and then you compare. So let's do the same thing here. Replace x with negative x and compare it to the original. Negative x to the third power plus 3 times the absolute value of negative x. If you raise a negative to an odd, that is a negative value. And if you take the absolute value of a negative, well, that's the same as the positive. Okay, so we compare. Are these the same things? No, they're not. Right? This has a negative in front of the x cubed, and that one does not. So it's not going to be even, right? This tells us that it's not an even function. So now we make the whole entire thing negative. Okay, this is our next comparison. Make the entire function negative, and then compare the blue and the red. So when we make the entire function negative, there's your negative x cubed, but then this is a minus 3 absolute value of x. Okay, so are these things the same? No, because this one has a minus 3x and that one doesn't. That means this is not odd either. So this graph, this function, would be neither even nor odd, right? It fails both of our tests. It fails our even function test, and then it also fails our odd function test. Now, what about from a graph? What type of symmetry does an even function have? Excellent. It has y-axis symmetry. All even functions have y-axis symmetry. They can be folded down the y-axis, down the middle, and the left side is the same as the right side for even functions. Okay, and for odd functions, okay, they pretty much always have to go through the origin, because in order to have origin symmetry or rotational symmetry, we have to go through the origin. So odd functions have origin or rotational symmetry. If we spin them upside down, they look the same as when they did beforehand. Okay, now what if we were looking at numbers? Okay, numerically, for every xy we have on our graph, there is a corresponding negative xy. The y values don't change on an even function, right? The y values stay the same. If they started negative, they're going to remain negative. But the x values change. So there's a positive and there's a negative with the corresponding same y. That's how you know it's going to be an even function. And for odd functions, they both change signs. Both of them change signs. That's how we know it is a odd function. They change signs. Okay, so that's everything you never wanted to know but need to know about odd and even functions for your comprehensive test in a couple of days. Okay. Oh, so number 8 is asking us that question. If g of x is an odd function and 7, negative 2 is a point, what other point must be on the graph? Okay, so we just got over saying that every point has an opposite point on the graph if it's odd. Which means if I have the point 7 comma negative 2, that's going to end up at negative 7 and positive 2. Right? Both of your numbers change their signs. So we had a positive became a negative. We had a negative became a positive. That's true for all odd functions. Okay, how do you know if an inverse of a graph exists? So you do something called the horizontal line test, right? You do the horizontal line test, and if it crosses more than once, then the inverse does not exist. So in this case, this one passes the horizontal line test, so this is a one-to-one function, and the inverse exists. So if your graph passes the horizontal line test, then that graph is a one-to-one function, which means the inverse exists. Okay, as opposed to this example here, where we're going to have lots of failures. So there's 2 intersections there, there's intersections here. This whole entire horizontal line, right, all bad. So this is not a one-to-one function. There are multiple y values from multiple x values. Okay, so in this case, the inverse does not exist because it is not a one-to-one function. Okay, so it's about being one-to-one, whether the inverse exists or not. And our last one is some algebra, right? It says, find the inverse of h, which is a quadratic with a restriction. Okay, so this quadratic expression, 1, 2, 3, 4, 5, 1, 2, right, that's where the vertex is. We're only talking about the right side of the graph. Right, that's what this restriction means, only from greater than negative 5. So this greater than negative 5 is not a part of our function that we're going to be evaluating. Right, the only reason this is here is because it makes this now a one-to-one function. If it were the whole entire quadratic, we would also have the left side, and it would fail that horizontal line test, and the inverse wouldn't actually exist. So the x greater than or equal to negative 5 is not a part of our inverse function. So inverse is found by simply switching the x and the y coordinates. I don't want to say coordinates, but variables. Wherever there used to be an x, now there is a y. Wherever there used to be a y, now there is an x. That's the first step in writing an inverse. And now we do all the math. So we'll add 2 to both sides. X plus 2 equals parentheses y plus 5 squared. Okay, now to get rid of the square by square rooting both sides. Okay, so now we have a square root function equals y plus 5. And our last step is to minus 5 from both sides, okay, which always goes after your radical ends. Right? We don't ever subtract underneath the radical. So it's not 2 minus 5 equals minus 3. No, you never subtract or add or distribute into a radical. And since the name of this was h, this is now going to be h inverse. Right? We replace your y letter with the functional notation appropriate for inverse. So if we were going to sketch a graph of this, right? If we were going to sketch a graph, we would come up here to our original function and we would make some points, right? Some x's and some y's. We know that at -5, the y value is -2. We can calculate that at -4, the y value is -1. We can calculate that at -3, the y value is 2, because these are some points that we can have for your function, right? That's your given function, -5, -2, -4, -1, and -3, 2. You do that by replacing x with -5, and then replace x with -4, and then replace x with -3, and calculate it. Right? This is an Algebra 1 type calculation. You just have to add, square, and subtract 2. Now for your inverse, we're going to switch the y's and the x's. So this will be -2, -5, and -1, -4, and 3, -2. Nope, that's wrong. 2, -3. Right? If you have points, you simply switch the x's and the y's, and then you graph it appropriately. So this would be the inverse, right? That's our square root function, 2 left and 5 down, which is the reflection of our line. So there's all this stuff's about inverses across the line y equals x. That's the reflection line for an inverse. Okay, that's a lot of stuff, but a lot of algebra. So make sure that you know everything about everything. Just kidding, just most things about this stuff. 20 questions, multiple choice, up to an 80. Good luck.